The first commercial nuclear power plant began operating in the US in 1958, and there are now about 100 of them. Together, they generate a fifth of all electricity generated in the US, without releasing any carbon emissions or air pollution. The same can't be said for the natural gas and coal-burning power plants that are still used for 60% of the electricity in the US. But that could all be changing. A new generation of nuclear reactors is in development and could lead to less expensive, easier to build, and safer to operate reactors, meaning our electrical future could increasingly be a nuclear one. Although numerous advances have been made in the safety and efficiency of nuclear reactors, the basic principles are the same today as they were decades ago. The nuclear reactor's fuel source is enriched uranium, pressed into pellets. These pellets are an incredibly dense form of energy. How dense? Let's let a nuclear energy influencer named Isodope explain in one of her videos.
Uranium pellets are the fuel used in nuclear power plants, and just like gummy bears, they're super dense, which just means they're small but have a lot of energy inside. One uranium pellet, roughly the size of a gummy bear, okay, you get it by now, has as much energy as 149 gallons of oil, 2,000 pounds of coal, or 12,000 Big Macs.
At its core, the nuclear reactor is a water boiling machine, kind of like a kettle. But instead of burning fossil fuels to create the needed heat, the nuclear reactor hurls neutrons at atoms of uranium, a naturally radioactive element. These neutrons cause the uranium to split apart and release a tremendous amount of energy. In most reactors, that energy is used to heat pressurized water, which is then used to heat water in another vessel that generates steam and turns an electrical turbine. It's a process that's essential for a large portion of the world's energy supply.
Today we have about 440 reactors in the world. They produce about 10% of all electricity supply in the world, which is actually more than wind and solar. Through the development of the nuclear industry, we've actually avoided something like 60 gigatons of CO2 emissions over the past 50 years.
What hasn't changed much since the first commercial nuclear reactors came online in the 1950s is the time and cost needed to build them. Building a nuclear power plant requires a massive upfront investment of money and time.
Reactors that are being built now are often, the scale of investment is something like $10 billion. And that needs to be put up front during that 10-year construction period.
The billions needed in startup costs can hinder the construction of nuclear power plants and leave regions dependent on coal and natural gas, especially in areas that are not well suited for hydro, wind, or solar power. That's where the concept of small modular reactors comes into play. These reactors use cutting-edge technology and offer the promise of smaller and faster nuclear energy for a lot less money. One company leading the way is X Energy.
So with the old traditional light water reactors, it takes them about 10 years to build this plant. So for 10 years, you can just imagine all the money that you need to build this plant. So you go and you take a loan out for 10 years, and only after 10 years, you can start repaying your loan. But with our reactor, after 2 years, you immediately start to earn revenue.
X Energy recently received $80 million from the US Department of Energy to help build its futuristic reactors. It's not just the small size that could make X Energy's new design a game changer. This reactor uses helium gas instead of water as a method for transferring heat from the nuclear fission to the boiling water. This could make for a very efficient reactor that operates at extremely high temperatures.
We heat up the helium from 250 degrees centigrade to 750 degrees centigrade.
Perhaps the most incredible aspect of this new reactor, and possibly the biggest game changer in terms of how the public thinks about nuclear energy, the X Energy reactor cannot have a meltdown. At least that's what the company building it is saying.
The XE100 will be the first that is meltdown proof, so our core cannot melt down. It is walkaway safe, so no matter what you do, the core cannot be damaged or melt down.
The Department of Energy also gave an $80 million grant to fund research into a new reactor design, this one from a company called TerraPower. TerraPower was founded in 2006 by Bill Gates. Gates has said that nuclear is ideal for dealing with climate change because it's the only carbon-free, scalable energy source that's available 24 hours a day. TerraPower's experimental design is called the natrium reactor. Natrium is Latin for sodium, which is why the abbreviation for sodium on the periodic table is Na. Gates' company calls its reactor natrium because instead of using water or helium, the reactor uses molten sodium metal. This molten sodium metal is used to heat up salt. This hot salt can be used to boil water and run the steam turbine, which generates power. Or it can be stored on site and used to generate additional power when needed.
We do have incredible challenges for the climate. If we're going to have enough energy for the world and not further impact the climate, we really need carbon-free sources of energy. And nuclear is just a very elegant solution. And in fact, it's been nuclear science has really been under-harvested. There's things we're doing today in nuclear science that really should have been done 20 years ago. In the US, there's really strong bipartisan support for nuclear energy and advanced nuclear energy.
It's clear that the next generation of nuclear reactors could be an important part of freeing us from fossil fuels. It just remains to be seen how widely accepted they'll be. If scientists can show the public that the next wave of nuclear power is much safer, we could be maximizing one of our most effective tools in fighting the climate crisis. That is, while we continue to wait for the holy grail of fusion power.